Okay, right now we are looking at a agent-based model. This model is called ANT model. The original code is from the NetLogo textbook, chapter 1, ANT model. In this video, we are going to answer 3 questions. The first question is, what does this ANT model do? To answer this question, we will examine individual ants' behavior, and we will try to understand what does the term complex mean, or what does complex pattern mean. The second question we're going to answer is, in what ways we say agents-based modeling is similar to machine learning and deep learning. And third question we're trying to answer is, how can we validate our model? How do we know our model actually can simulate the real phenomenon in the natural world? So we need to use complex pattern to validate our model. How do we do that? So let's look at the first question first. What does ANT model do? Basically, this model tries to code up individual ants' behavior, and then we create many ants. For example, we can create 130 ants and ask them to behave in the same way, following the same rules. And then the model can demonstrate to us, can show us how ants colony as a whole behave. It will show us complex phenomena, complex patterns. That is what this model tries to do. So first of all, let's look at what individual ants can do. So we set the number of ants to be 1, and we can set up the other parameters. And then we can ask the ants to move. So we can slow it down. So there are 3 actions. The first one is looking for food and wander around. So this is the ant is looking for food and wander around. And then he may find food or may not. Okay, once he finds food, we see food. So that's a second action. And then once he got food, the ant will carry the food to the nest. And then we send the ant out to looking for food again. So basically we can say every single ant has these 3 actions. Okay. Right. And now, once we code up any individual ant's behavior, we can create a bunch of them and ask them to behave like ant colony, how ant colony behave. Now, let's create 130 ants. And we set up the world for them, and we send them into the world. We can see they take up 1 pile of food first, and then another pile of food, and then the last pile of food. Okay, we can do it again, make it faster. Now this time it seems that both food is gone at the same time. Let's try again. Now this pile first. Okay, this 2 and this, and then this one. But the last 2 seems the ant colony devoted equal amounts of efforts to get those 2 piles of food. Now this finish at the same time. So that is very complex phenomenon because we would assume that given the two pile food have equal amounts and they are they have the same distance to the nest, so we would assume both pile food will be um, disappear at the same time because there should be no prejudice against one food over the other. That is our assumption, and it's logical. And our model seems to support that, at least previously in previous runs. It seems to support that, but this runs, let's finish one first. Try again. Okay, this one slightly faster. Okay, this part first, and this pile second, and then this pile. Try again. This one first. Okay, almost as finish at the same time. Okay. So we would assume with the same amounts and the same distance, the ant colony will trying to gather these two piles at the same time. However, in reality, biology says even with the same amount and the same distance, the ant colony will still decide to devote most of their efforts to gather one pile of food, to get that one pile of food first, and then to the second pile. It will not do two piles at the same time. But our model um, seems not strongly or largely behave in a way as the biologists suggest. So maybe this is something we need to improve. But come back to uh, the essential question we're trying to answer in this video. That is, what is complex pattern? The complex pattern in one sense is that the phenomenon, the pattern, the ant colony trying to perform or demonstrate is the pattern that's beyond our assumption, beyond our prediction. For example, we would assume same amounts and same distance, two pile of food will be gathered at the same time. But the biologist says, according to what they observe, the ant colony will choose one pile over another and devotes the majority of the efforts to that pile first. So that is beyond our assumption, beyond our prediction. We consider that something we cannot easily foresee is complex. And another understanding of the complex is it's very difficult to program. Sometimes the pattern, like the one we just described, is kind of too difficult to program. And we don't even know where to start to program the ants in terms of behavior in order for the whole ant colony to behave in a way which as the biology suggests. So that is how I understand as complex.